We're now going to look at lesson number 2, error in measurement. This is also in your topic 4, practicalities of measurement booklet. So we're going to look at that first example on page 10. So part A, what is the length indicated by the arrow on the ruler? And for that one, it should be pretty easy to see that the length is 38 centimeters. For part B, what is the precision of the instrument? This ruler is precise to 1 centimeter. To calculate the absolute error of the instrument, we just take the precision and multiply it by 1/2. So when we perform that calculation, we find that we will be precise within 0.5 centimeters. Part D, what are the limits of accuracy for this measurement? So we're trying to find the upper bound and the lower bound. So from part C, our answer was plus or minus 0.5 centimeters. So for our lower bound and upper bound, we just subtract that 0.5 centimeters from the length indicated on the ruler. And for the upper bound, we add that 0.5 centimeters to the length indicated by the ruler. And last but not least, we're finding the percentage error. We find our percentage error by dividing the absolute error by the measurement. So for this question, that would be our answer from part C, so that 0.5 divided by our answer from part A, and that's 38. So our calculation is 0.5 centimeters divided by 38 centimeters, and then we multiply that by 100% because we are looking for the percent error. And when you check that into your calculator, you should get 1.3%. So for example number 2, part A, what is the RPM indicated? So that is roughly 7. And I'm going to write it as 7,000 RPMs. Next, what is the precision of the instrument? Well, we can see that it's precise to 500 RPMs because of that little line that falls in between every 1,000. The absolute error of the instrument is precision multiplied by 1/2. So that gives us plus or minus 250 RPMs. Our limit of accuracy, so we're looking for our upper bound and our lower bound. That would be our measurement, so that's from part A, plus and minus that absolute error that we just found. So I'm just going to use UB for upper bound and LB for lower bound. So our upper bound, that was 7,000 plus 250 to get 7,250, and our lower bound was that 7,000 subtract 250 to get 6,750. And our percentage error, that's our absolute error divided by the measurement. And then we sub in what we know. So our absolute error was that 250. Our original measurement, that was the 7,000, so we divide 250 by 7,000 and multiply by 100%. And correct to 1 decimal place, you should get 3.6%. So now we're looking at question 1 on page 11. Hillary has her height measured at 164 centimeters, that's to the nearest centimeter. What are the limits of accuracy? So just remember that our limits of accuracy, that's our upper bound and our lower bound that we have to calculate. So to find our upper bound and lower bound, we need our measurement as well as the absolute error. So we are told the measurement, that's that 164 centimeters. And our absolute error, that was our precision multiplied by 1/2. So our precision for this question, they're telling us that it's given to the nearest centimeter, so that means that our precision is 1 centimeter. And 1/2 of 1 centimeter gives us 0.5 centimeters. So I just plug that into the equation just up here. So now our upper bound and lower bound will be 164 plus or minus that 0.5 centimeters. So you should get that your upper bound is equal to 164.5 centimeters and your lower bound is equal to 163.5 centimeters. And similarly for question number 2, I'm just going to erase what we filled in at the top there. So we are told for this question that the mass of the trailer is 260 kilograms, so that's our measurement. And now we need to find our absolute error. So that's our precision times 1/2. And for this question, we are precise to the nearest 10 kilograms. So our absolute error for this question will be 5 kilograms, and that's what we're going to add and subtract from 260. And now that we have all of that information, we can determine what our upper bound and lower bound will be. So our upper bound will be 265 kilos, and our lower bound will be 255 kilos. For question number 3, we're trying to find the percentage error, and we're given the capacity, so that's our measurement, is 65 liters. So this is our percentage error formula that we're going to be filling in. So we know what our measurement is, but we still have to determine what our absolute error is. And remember, the absolute error is the precision multiplied by 1/2, and we're told that this capacity is given to the nearest liter, so that means that our precision is 1 liter, and we're multiplying by 1/2. So there is our absolute error, it's 0.5 liters. And that was the last piece of the puzzle that we needed. So now you can plug that into your calculator, and you should get 0.77%. Question number 4a, we're looking for the smallest unit of measurement. So we're given 4,500 grams. There are no decimals there, so the smallest unit of measurement would just be 1 gram. For part 2, the absolute error, that's just 1/2 of the smallest unit of measurement, so 1/2 of 1 gram is 1/2 of a gram. For part 3, the limits of accuracy, so that's our upper bound and lower bound, so we are adding and subtracting that 0.5 grams from 4,500 grams. For question B, we're given 35.8 grams. The smallest unit of measurement for this one, since we do have that decimal place, the smallest unit of measurement would then be 0.1 grams. Part 2, absolute error, again that's just 1/2 of the number we found for the smallest unit of measurement. And part 3, the limits of accuracy, we are then adding and subtracting that 0.05 grams from 35.8. And I've just added in that plus and minus to the absolute error there. Question C, we're looking at 25 minutes. The smallest unit of measurement there, since there's no decimal, would just be 1 minute. Part 2, the absolute error, again that's just 1/2 of a minute. And for the limits of accuracy, we're just adding and subtracting that 1/2 of a minute from the 25 minutes. And looking at question D, we have 42.35 kilograms. We're looking for the smallest unit of measurement first. So we have these 2 decimal places. The 3 is in the tenths column, the 5 in the hundredths. So the smallest unit of measurement for this one would be 1/100th, or 0.01 kilograms. The absolute error is again just 1/2 of that smallest unit of measurement that we found. And the limits of accuracy would be adding and subtracting that absolute error from the 42.35 kilograms. Now we're going to look at filling in the table on page 12. So with whole numbers, it's pretty straightforward. So we're told that the measurement is 56 seconds. So the smallest unit of measurement there would just be 1 second. The absolute error is 1 second multiplied by 1/2 to give us plus or minus 0.5 seconds. And our limit of accuracy would be that 56 seconds plus and minus 0.5 seconds. So next we have 3.4 milliliters. So when you see a decimal, it's not rounded to the nearest milliliter, it's actually rounded to the nearest tenth of a milliliter. So we write that as 0.1 milliliters. The absolute error there is again the same thing, it'll just be half of that 0.1 milliliters. So that gives us 0.05 milliliters plus or minus, and our limit of accuracy would be that 3.4 plus or minus the 0.05. Next, we're told that we have 600 kilograms, and it's rounded to the nearest kilogram, so they kind of gave you the smallest unit right there. It's rounded to the nearest 1 kilogram. Our absolute error is half of that. And then we're adding and subtracting that 0.5 to that 600 kilograms. Alright, this one's just a little bit different, so we're given 600 kilograms, and we're told that it's rounded to the nearest 10 kilograms. So for this one, the smallest unit would be 10 kilograms. Our absolute error will be half of that, so that's 5 kilograms. And then we're adding and subtracting that 5 kilograms to the 600 kilograms. So now we need to calculate the percentage error for those last two measurements. So I'm going to represent this 600 kilos to the nearest kilogram with red, and the 600 kilos to the nearest 10 kilos in blue. So when we sub in what we know into our percent error formulas, we get that 600 kilos to the nearest kilogram gives us a percent error of 0.083%. And for the 600 kilos to the nearest 10 kilos, our percent error is 0.83%. So which of the two measurements is more accurate? Well, it would be the one to the nearest kilogram, because our percent error is smaller. So it's more likely that we would have an error when we're rounding to the nearest 10 kilos.